Hello everyone, let's talk about this question. It's called Raspberries. We are given an integer array a1 to an and a number k which is between 2 and 5, and we can perform one operation on all of these numbers in the array, and that is just that we can increase that number by 1. Now our goal with increasing this number by 1 would be to make the product of the array divisible by the number k that we have been given. Quite an interesting question, but let's see what our inputs are. We are given that we have test cases, input t. The first line will have two integers, n and k. N is the size of the array and k is the number we want to make sure the product of the array is divisible by. The second line will just have all of the numbers that we are inputting inside our array. Now we can see the basic idea of this question. The basic, most intuitive thought would be multiply all the numbers in the array and find if they are divisible. This is interesting, but this will take a lot of time and could be potentially bad. So we can't do that, but we can do something else, which is quite an interesting trick. Think of it like this. Let's say we are given two numbers. We are multiplying two numbers, a and b, and let's say that multiplication of a and b is equal to c. We can say that c is divisible by a and c is divisible by b. We'll be using the same idea as that in our solution as well. So let's look at one of the examples and let me explain. We can look at the first example that we're given, 2, 5 and then 7 and 3. We are given 2, 5. The 2 here is the size of the array and 5 is our k, which is the number that we want to make sure the product is divisible by. And the numbers that we have been given inside the array are 7 and 3. Now when you think about this, we can see that the current multiplication is 7 times 3, which is 21. But what we're essentially doing with this 21 is we are multiplying 7 and 3 in this case right now. But as we saw here, that a times b, when that multiplication is equal to c, we can say that c is divisible by a or c is divisible by b as well. By the same logic, we have to make one of these values, 7 and 3, equal to or divisible by 5. And the best way to do that, since we can only increase the number and not decrease it, we can add 2 to the 3 that we already have, and that would essentially make it 7 times 5, which is 35, which is divisible by our key value or k, 5 here as well. That is the crux of this question. But this sort of process only really works with the following values, 2, 3 and 5 in our limits that we have been given. Obviously it works with a lot more, but in our universe it works with 2, 3 and 5, but doesn't work with 4. And the reason why it doesn't work with 4 is because 4 is not a prime number. 2, 3 and 5 are, and prime numbers only have two divisors, 1 and itself. We know that if k was given to us to be 2, 3 or 5, we would have a easier time to figure out the solution. But let's see what our potential solution would be. Now think about this, what we did in the question that we solved just before. We increased the number 3 by 2. We could have also decreased the 7 number by 2, but we weren't allowed to do that because of the question. If we were allowed to reduce numbers as well, it would be pretty easy. We would just look at the number that we have and use a modulo operation with our key value k, and that would be our answer. Now we will eventually have to go through each of the values inside the array and minimize this answer. So we would just have to take the minimum of all of this. But this is not the case right now because we cannot decrease values. And to make sure we can still find the solution, all we have to do is subtract k from this modulo number. We can see that in the example that we did here as well, with 3 becoming 5, or increasing 3 by 2. Let's put these numbers. So our k in that case was 5 minus our number was 3, and we were doing 3 modulo 5. 3 modulo 5 gave us 3, and then it just becomes 5 minus 3, and that makes our answer 2. So this is the idea that we will be using, k minus the number modulo k, and we will go through each of the values inside the array and try to minimize this. So we'll be using minimum. Let me reduce the or erase this because this is not the correct answer. We'll be using this one. We talked about the core idea behind our math solution here, but the interesting part is that it only really works for 2, 3 and 5. For number 4, so if k is 4, now let's think about this. If k is equal to 4, we can make 4 by multiplying 2 times 2. If we're able to find this structure in our array, we know that the whole array is divisible by 4, because 2 times 2 is 4, and if we can find there's a system where there's 2 2's being multiplied, we can say that the whole array is divisible by 4. And the way we can find out if there's 2 2's being multiplied is just by checking if there are 2 even numbers. So we'll check the number of even numbers. For example, this essentially breaks the k equals 4 situation into 3 cases. Let's go through each of them. Case 1 is where number of even numbers is greater than or equal to 2. In this case, we know if there are 2 or more even numbers, they will be, or the whole array will be divisible by 4, and therefore our answer in this case would just be 0 because it's already divisible by 4. Our case 2 here is if number of even numbers is equal to 1. In this case, we know that the array has 1 even and all others odd. Now the best thing that we can do here is just increase one of the odd numbers by 1, and when we do that, we will now have 2 even numbers. So our answer in this case becomes 1, because we just have to flip one of the odd numbers into an even number, and the best way we can do that is by increasing that odd number by 1, and after that we'll have 2 even numbers. And finally, case 3 is when number of even numbers is 0. When we don't have any even numbers, all of the numbers are odd. All numbers in the array are odd. In this case, the best thing for this situation we can do is to just increase both or find any two odd numbers and increase that those values by 1 each. So when we increase two odd values by 1 each, we will have 2 as our answer. The k equals 4 situation will not work independently. We would still have to compare these answers to our solution that we found using these, because there's a possibility that these values that we will find using this formula will be better than the solution that we'll find using our three cases when k equals 4. But this only happens when k equals 4, so we don't have to do this for 2, 3 and 5. That is the basic idea of the question. Now let's get into the code and see how that looks. I will start off with my Codeforces template, and we will take in test cases. While test cases is positive, we will input two values, n, which is the length of the array, and k, which is the k value or the number that we have to make sure the product is divisible by. We'll input all of these, and then we'll make a vector of integers. We'll call it num list and initialize all of them to the size of n with the value 0. Now for int I equals 0, I less than n, I plus plus, we will input the values inside the numbers list. Now we have to figure out or run through our main loop. For this, we will initialize a diff variable. We can also call it answer if you want to, and this will be the maximum value an integer can take, because we're trying to minimize the solution. If we were trying to maximize the solution, we would have taken the minimum value when initializing. After the answer integer that we will be using, we will initialize the count of even that we will be using in the case that k is equal to 4. So we will just say is, or rather even count. We will initialize that count to 0. Now our main for loop here is going to run through the array, and initially we will just be counting the numbers on number of time an even number occurs, which will be using this. And the other loop here would look something like this. So as we're going through all the values inside numbers list, we will check if number list at the position I modulo k equals 0, because if it is 0, then we know that the whole product of the array is divisible by the value k, and at that point we just have to make sure that our answer variable is 0, because we don't need to change anything. If that is not the case, we will be using our formula that we made up before, which is just going to look like this. Our current diff or difference is equal to k minus number list at I modulo k. This is going to be incredibly helpful. Now we have to minimize that answer, so we can use a min function between the answer that we have and the current diff that we just calculated. This is done for all of the values other than 4, so this part of the code works for everything other than 4, and maybe in sometimes for when k equals 4 as well. But there are a few other situations where we have to explicitly mention what those cases are and figure out those answers for ourselves when k equals 4. So we're going to do that here. If k equals 4, we saw that we had three cases. If the number of even numbers is greater than or equal to 2, we know that our answer is 0, because the number is already divisible by the number 4. Else if the number of even numbers, so even count is equals 1, we our answer would be the minimum of the answer that we had found in this part of the code and 1, because when we have one even number we can switch one of the odd numbers to an even number by just adding 1, and that is why we are calculating the minimum of answer and 1. Now the last case here is if the count of even count here is 0, we will have to find the minimum of answer and the number 2, because in the case where all of the numbers are odd in an array, we can flip two odd numbers into an even number by adding 1 and 1 to each of them. So that's why the number 2 in that case. After we've done all of that, all we have to do is see out our answer variable, and that is it for the question. Obviously, since we used vectors here, integer max here and min here, we will have to include vector, climit and algorithm. That is the code. If you can find a better or more optimized way to solve this, I would love to know that. Thank you so much for watching this video. I'll see you soon.